Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. So, in today's video lecture, I am going to discuss about the Kirchhoff laws and what are the problems on Kirchhoff laws and what is the procedure involved in the Kirchhoff laws. Okay, so here in today's class we need to discuss about the what is the definitions of the Kirchhoff laws. So the Kirchhoff laws are classified into two types. First one is the Kirchhoff voltage law and second one is Kirchhoff current law. So KVL and KCL. Okay, and what is the procedure of the Kirchhoff law and some problems on the Kirchhoff laws that we'll discuss in the today's video lecture. Okay, so here the definition, what is the definition of the Kirchhoff law? So here basically the Kirchhoff laws which is classified into two types. So first one is the Kirchhoff voltage law and second one is Kirchhoff current law. Okay, so here the Kirchhoff voltage law is nothing but it states that the algebraic sum of the total voltage drop in a closed loop is always equal to 0. Okay, so the KVL states that the algebraic sum of the total voltage drop across each and every element is always equal to 0. We can call it as a Kirchhoff voltage law. Okay, so here for example I am taking the one circuit here. So I am taking the two resistors and here we are having the source. So plus minus voltage is V. This is the resistor R1 and this is the resistor R2. Okay, so here R1 and R2, these two are in series. In series current is constant but we are having the different voltage drops. Okay, so here current is constant means current through R1 and current through R2 will be same only, but we are having the different voltage drop at R1 and R2. So at R1 the voltage drop is V1, at R2 the voltage drop is V2. Okay, so here at R1 we are having V1, at R2 we are having V2. Now for this given single loop circuit we need to assign the polarities. So here the polarities are depends on the current direction. Okay, here it is a one single loop. So in this loop the current direction is clockwise direction. So here the current direction is clockwise. So we have to give the polarities as per the current direction, that is plus minus plus minus. Now apply KVL. So I am starting from here, plus V minus voltage drop at R1 is I into R1 minus voltage drop at R2 is I into R2, or V equal to I is the common term, so I into R1 plus R2, or I equal to V divided by R1 plus R2. Here is the calculation of the current by using the Kirchhoff laws. Okay, so in this Kirchhoff laws, this is the main equation of the KVL, right? Similarly, Kirchhoff current law. So Kirchhoff current law is nothing but total the algebraic sum of the incoming currents. The algebraic sum of the incoming current is equal to the algebraic sum of the outgoing currents. We can call it as a Kirchhoff current law. So Kirchhoff current law states that the algebraic sum of the incoming current is equal to the algebraic sum of the outgoing currents. We can call it as a Kirchhoff current law. Okay, here for example I am taking this some simple directions here. So these are the current directions. Let us take, this is I1, this is I2 and this is I3, I4, I5, I6 and this is I7. Now as per the Kirchhoff current law statement, the algebraic sum of the incoming current means at this node point we are having the incoming currents. So what are the incoming currents? I2. So I am writing here I2 is the incoming current, and I3 is the incoming current, and I6 also incoming current, and I7 also incoming current. That is algebraic sum means we have to add a plus here. So I2 plus I3 plus I6 plus I7 equal to, so algebraic sum of the outgoing currents means leaving from the node point. So we are having the currents here leaving from the node point is I1 is there, and I4 is there, and I5 is there. So I5 is the last one. So here I1 plus I4 plus I5. So these are the incoming currents and these are the outgoing currents. Now finally we have to write equation like this: I1 plus or minus I2 plus or minus I3 plus I4 plus I5 plus or minus I6 plus or minus I7. That should be equal to 0. Now finally this equation we can write like this: summation of I equal to 0. So what is the meaning of the summation of I equal to 0 means? So here the algebraic sum of the total currents, meeting at a single node point is always equal to 0. That is the another definition of the Kirchhoff current law. Okay, so these are the definitions and the solution of the Kirchhoff voltage law. That is first one, and second one Kirchhoff current law. Okay, now what is the procedure? So procedure to solve the problem. So what is the procedure involved in the Kirchhoff law? So here we are having the procedure of Kirchhoff laws. So in that, step 1, what is step number 1? Step number 1 is, first we have to find out the total number of loops in a given circuit. First of all, we need to find out the total number of loops in a given circuit, and second step is we need to give the current direction. We need to give the current direction through each and every element. Okay, so if it is a clockwise direction, so we have to give the clockwise current direction. If it is a anti-clockwise means we have to give the anti-clockwise current direction. Okay, so here step number 2 is we need to give the current directions through each and every element. That is step number 2. Now step number 3. So step number 3 is we have to assign the polarities. We have to assign the polarities at each and every element. So polarities means plus minus. We have to assign the polarities at each and every element. That is step number 3. And step number 4 is we need to apply the Kirchhoff voltage law, KVL. Right? We need to apply the KVL in each loop. And finally, the step number 5 is we have to find out the response of the each resistor, if it is a current or if it is a voltage or if it is a power. Right? So suppose for the resistor, we need to calculate the current through the resistor and voltage drop across the resistor and power at resistor. Okay, we need to calculate. So here these are the steps, or these are the procedure of the Kirchhoff laws, right? So now we'll go for the problems. So here I am taking the one problem here. So here is the question: evaluate the current through each resistor. Evaluate the current through each resistor and also find the power across 8 ohm resistor. Here is the question. okay, by using the Kirchhoff laws. By using the Kirchhoff laws, we need to calculate the current through 4 ohm, 6 ohm, 10 ohm and 8 ohm, and also we need to find out the power through 8 ohm resistor. Okay, so in that, the solution for this problem is, so what is step number 1? Step number 1 is, first of all, we need to find out the total number of loops in a given circuit. So we are having the 2 loops here. This is loop 1 and this is loop 2. We are having the 2 loops. So step number 1 is, we are finding the total number of loops. So number of loops are 2. So the required currents are 2 only, that is I1 and I2. So first loop current is clockwise direction, second loop direction also clockwise direction. So I am taking the current direction like this, I1 first one and second loop current I2. So means current through 4 ohm is I1, current through 6 ohm is I2. And what about current through 8 ohm? That is also I2 only, because 6 ohm and 8 ohm are in series. In series circuit, current is constant. Now from this node point, current is dividing. Now what is current through the 10 ohm? Means it is I1 minus I2. Here is the current direction, that is step number 2. Step number 2 is current direction. So we have to give the current directions through each and every element. So at 4 ohm, current is I1. At 6 ohm and 8 ohm, current is I2. At 10 ohm, current is I1 minus I2. That is step number 2, current direction. And the third step is, we need to assign the polarities. Plus minus. We need to assign the polarities, right? So the polarities are depends on the current direction. Okay. So here is plus minus. So here also starting from plus minus, and this is plus minus, and here also plus minus, and this is also plus minus, right? Now the step number 4 is apply KVL. Apply KVL in loop 1 and loop 2. Now we have to apply KVL in first loop and second loop. So here in this case, I am starting from here for the first loop equation. I am starting from this point. When I am starting from this point, always we need to take the first polarity or second polarity. Okay, take any one polarity. Okay, so here I am starting from here, so I am taking the second polarity. So when I am starting from this point, we have to take the second polarity, that is positive. So plus 20. So plus 20. Now at 4 ohm, the second polarity is minus. So minus 4I1. Minus 4I1. And the current direction is like this. Now at 10 ohm, the second polarity is minus. So minus 10 into I1 minus I2. And here there is no more elements. Okay, this is the starting point and also this is the ending point. So this is the starting point and also this is the ending point. So minus 10 into I1 minus I2, that should be equal to 0 because there is no more elements. Now simplify the equation. 20 minus 4I1 minus 10I1 plus 10I2 equal to 0. Now, so for minus 4I1 minus 10I1, that is 14I1 minus 10I2, that is equal to 20, right? So here this is, let us take as equation number 1. Now apply KVL in second loop. So now in second loop, I am starting from this point. So this is the starting point and also this is the ending point. Okay. So we'll go for the clockwise direction, right? So at this node point, the second polarity is minus 6I2 and at 8 ohm minus 8I2. Next, the current is here at this node point, current is upward direction, means plus 10 into I1 minus I2, and there is no more elements, that should be equal to 0. So now simplify the equation. Minus 6I2 minus 8I2 plus 10I1 minus 10I2 equal to 0. Now by solving this equation or by simplifying, plus 10I1 minus, so minus 10I2 minus 8I2 minus 18I2 and minus 6 minus 24I2 equal to 0. Let us take as equation number 2. Now by solving equation 1 and equation 2, we'll get I1 equal to 2.033 amperes and I2 will get 0.847 amperes. Okay, so here is the question. Evaluate current through each resistor. Evaluate current through each resistor means at 4 ohm, at 6 ohm, at 8 ohm, at 10 ohm. So here at 4 ohm current is I1, that is equal to 2.033 amperes. At 6 ohm and at 8 ohm, so current is I2, that equal to 0.847 amperes. Similarly at 10 ohm, so current is I1 minus I2, that is 2.033. So 2.033 minus 0.847 will get 1.186 amperes. Okay, these are the current at 4 ohm, at 6 ohm and 8 ohm and at 10 ohm. So current through 4 ohm is 2.033 amperes and current through 6 ohm and 8 ohm is 0.847 ampere and current through 10 ohm is 1.186 amperes. So these are the current through each and every element. And here, and also we need to find out the power across 8 ohm resistor. So this 8 ohm resistor, we need to calculate the power. So power through 8 ohm. So already we know the equation. P is V into I or I square R or V square by R. So here I am taking the I square R equation. Okay. So here I is nothing but current through 8 ohm, that is I at 8 ohm square into resistor. So what is the resistor value? 8. That equal to, so what is current through 8 ohm? 0.847 whole square into 8. Now by solving this equation, we'll get 5.739 watts. Here is the calculation of the given circuit by using the Kirchhoff laws. Okay. So here we'll go for the another problem also. Just I will give you the equations, how we can write the equation. So we are having the two sources here. So first primary voltage source is 30 volt, second voltage is 10 volt. So in this case, we are having the two loops here, first loop and second loop. So first loop current direction is clockwise, means I1. Second loop is anti-clockwise direction, means I2. Now I1 and I2 currents towards this point. From this point current is downwards. Now I1 and I2 are adding at this point. From this point current is downwards, means I1 plus I2. Now assign the polarities. plus minus, plus minus. And here anti-clockwise direction. As per the current directions, assign the polarities. Here already is there, plus minus, and here plus minus. Now apply KVL. So here plus 30 minus 5I1 minus 7 into I1 plus I2, that should be equal to 0. Okay, plus 30 minus 5I1 minus 7 into I1 plus I2 equal to 0. Now simplify the equation. 30 minus 5I1 minus 7I1 minus 7I2 equal to 0. Now here 12I1 plus 7I2 equal to 30. Let us take as equation number 1. Now apply KVL in second loop. The second loop equation, here I am starting from this point. So we will go for the anti-clockwise direction. So means plus 10 minus 9I2 minus 7 into I1 plus I2 equal to 0. So here for the second loop equation, I am starting from this point. So plus 10 minus 9 into I2 minus 7 into I1 plus I2, that should be equal to 0. Now simplify the equation. 10 minus 9I2 minus 7I1 minus 7I2 equal to 0. So 7I1, so 10 minus 9I2 minus 7I2 means minus 16I2, so plus 16I2, that is equal to 10. Let us take as equation number 2. Now by solving equation 1 and 2, we will get I1 value and I2 value. Now by solving the equation number 1 and 2, so here the equation 1 is 12I1 plus 7I2, that is equal to 30, and the second equation is 7I1 plus 16I2 equal to 10. So by solving the two equations, we will get, so I1 value is 2.867 amperes and I2 value is minus 0.629 ampere. So here you can see here I1 value we are getting positive, I2 value we are getting negative value. Why we are getting I2 as a negative? Because the second loop is anti-clockwise direction. The second loop is anti-clockwise direction, that's why we are getting negative value here. First loop is clockwise direction, that's why we are getting here, this is the positive value. Okay, so I1 is nothing but current through 5 ohm resistor and I2 is nothing but current through 9 ohm resistor. Now the current through 7 ohm resistor is I1 plus I2. Now if you can add these two, we will get I1 plus I2, that is 2.238 amperes. So these are the current through each and every element. Now we can also find out the power through 7 ohm resistor. So power through 7 ohm, that is I 7 ohm square into R. R is 7. That equal to what is current through 7 ohm? Means this one, 2.238 whole square into 7. Now here by solving this equation, we will get 35.06 watts. Here is the calculation. If two loops are in clockwise direction, here is the procedure. If one loop is clockwise direction and another loop is in anti-clockwise direction, here is the calculation. Okay, so thank you one and all.